Welcome to Algebra. Today we'll be studying section 6.1, simplifying algebraic fractions. We'll begin first with a vocabulary of what a fraction is. A fraction is in simplest form when the numerator and the denominator is relatively prime. In other words, the numerator and the denominator have no common factors other than 1. So we're going to start out with just a number sample. For example, 1636, using the GCF, we find that the GCF is 4. Since the GCF is 4, I'm going to write each factor. 4 times 4 is 16. 4 times 9 is 36. I can cancel the 4's, leaving me a fraction in simplest form of 4/9. If I was to do this using prime factorization, 16 is 2 to the 4th over 2 squared times 3 squared. Using the prime factorization and the rules of exponents, I have the same base here, so I subtract my exponents, 4 minus 2, so I have 2 to the 4 minus 2 over 3 squared. If I was to simplify 4 minus 2, I get 2. 2 squared is 4 over 9. So both methods work lovely for simplifying a fraction. We'll be using both of these ideas when we are simplifying algebraic fractions. We'll begin with example number 1. Beginning with example number 1, please take a moment to pause the screen and write down the 3 steps to simplify a fraction. We'll be using those 3 steps. Now that you have finished copying the steps to simplify a fraction, we will begin. We'll factor the numerator and the denominator completely. In the numerator, my GCF is 2, so I have n plus 4. In the denominator, my GCF is 3, so I have 3 times the quantity n plus 4. So I look, I have them factored completely, so I move on to step 2. Step 2 deals with the denominator. I look at each of these, and I can set each factor equal to 0 to see what would create a restriction. 3 equals 0 does not work. 3 will never be 0, so I don't have to worry about 3. But my next expression, n plus 4, may cause a problem. So I'm going to subtract 4 from both sides. N equals negative 4. My restriction now is n cannot equal negative 4. So when I get my final answer, I will also have the restriction written right there. Now that I've found the restriction, I will cancel the common terms. I have a grouping n plus 4, so I'll cancel both n plus 4, and I'm left with 2/3. My final answer is 2/3 with the restriction of n cannot equal negative 4. Moving on to example number 2. Again, our 3 steps are there, and we will begin with step 1, factor the numerator and the denominator completely. I will pull out a 3x for the GCF in the numerator, leaving me x plus 6. In the denominator, I will be pulling out a negative 2. I chose a negative 2 because I noticed right here in the numerator I had an x plus 6. And I recognized if I pulled out a 2, I would be left with an x and a 6, but the signs would be wrong. So by pulling out the negative 2, I end up with x plus 6. Again, at this point, I'm going to check with the denominator, and I recognize that my restriction, x cannot equal negative 6. Continuing from there, I'll go to step 3. I will cancel the common factors, x plus 6, x plus 6. My final answer is 3x divided by negative 2 with the restriction of x equals negative 6. Please be aware, you may also write this as negative 3x over 2. Either of those answers would be acceptable. The steps are no longer here, so you will need to refer to your notes when completing these. Problem number 3. I am going to look for a GCF. The GCF in the numerator is 4. I'm left with the quantity x squared minus 4. In the denominator, my GCF is 2, and I'm left with x minus 2. I note that in the numerator that I have a difference of 2 squares in the parentheses, so I will factor that, x minus 2, x plus 2, and in the denominator I'll copy the complete denominator, 2 times the quantity x minus 2. I will look for my restrictions at this time. My restriction will be x cannot equal 2, and now I will cancel. I cancel my common factors of x minus 2, and I know what I have 4 and 2. I can cancel the 4 to a 1, the 2 to the 1, and a 4 to a 2. In the numerator, I'm left with 2 times the quantity x plus 2. In the denominator, I'm left with a 1. I do not have to write that as a fraction any longer, so my final answer will be 2 times the quantity x plus 2 with the restriction x cannot equal 2. Moving on to example number 4. I'll begin this one. Sometimes I look at the numerator and denominator and try to determine which one's easier to factor. And I decide the denominator would be easier to factor, so I'm going to factor out a 3, and I'm left with x minus 4. The reason why I do that is sometimes by factoring the easiest part, I can look at the numerator and have a hint based on the denominator of how I could factor the numerator. So I see I have a negative 4 in the denominator, and I know negative 4 is a factor of negative 8. And negative 4 times a positive 2 gives me a negative 8. And in the middle, I need a negative 2x. So I recognize that negative 4 plus 2 will give me my negative 2x, so I have it factored completely. Step 2 is to find the restriction. So x cannot equal 4. And now I'm ready to cancel. I'll cancel the common terms, leaving me with the final answer, x plus 2 divided by 3. The restriction, x cannot equal 4. Okay, looking at example number 5. Again, I'm going to start with the denominator for factoring. I see I have an 8 and a 6. I'm going to factor out a 2 and an x. When I factor the 2 and the x out, I'm left with 4x plus 3. That gives me a hint of what possibly could be in the numerator. So I'm going to try to start with 4x plus 3 and see if it will help me out. I know that I have 4x squared, so I know I need an x here. And my last term is negative 6. And I know 3 times negative 2 will give me a negative 6. So I'm going to place that there, and now I'm going to check to see if this actually works. I check by doing this. 4 times negative 2 gives me negative 8. 3 times x is 3. Negative 8 plus 3 is negative 5. So I do have it factored completely. I will check with my restrictions. My restrictions will be 4x plus 3 cannot equal 0. I'm going to subtract 3 from both sides, leaving me with 4x cannot equal negative 3. Divide both sides by 4. My final restriction, x cannot equal negative 3/4. Now that I've completed that, I can cancel. And I'm left with x minus 2 divided by 2x. At this time, I had a completed answer. So I have x minus 2 divided by 2x with a restriction of x cannot equal negative 4. I do want to comment at this point. Sometimes students will note that we have a 2 in both the numerator and the denominator, and they will attempt to cancel those 2's. And then they will attempt to cancel the x's. These that cannot happen because x minus 2 is a group. It is in a symbol. If you think you may have that habit, please put parentheses around that because then that will remind you that x minus 2, that subtraction has to happen before the division bar occurring. So make sure we have x minus 2, the quantity, divided by 2x. All right, my final example is something a little bit different. We're still using algebraic fractions in the end, but this time we are solving for x. In order to solve for x, I have 3 steps listed over here on the right. You may pause and write that down, and then we will begin. Now that you have those steps written down, let's begin. Step number 1 says get all x terms on one side and all non-x terms on the other. So when I note I have a cx on the left and a minus dx on the right, I'm going to add dx to both sides. So I end up with cx plus dx plus d squared is equal to c squared. Now, I have the x's on one side, but I have an extra term here, d squared. So I'm going to eliminate that and move it by subtracting d squared from both sides. So I have cx plus dx is equal to c squared minus d squared. Now, when I look, I have both sides completed. X is on one side, all the other things on the other side. And now I'm going to go to step 2. I am going to factor both sides. On the left, I'm going to take the GCF out of x, so I'm left with c plus d. On the right side, I will factor this difference of 2 squares. I have c plus d times the quantity c minus d. Now that I have them completely factored, you'll note that I have a factor of just x. In order to isolate that x, I'm going to divide both sides by the quantity c plus d. When I divide both sides by the quantity c plus d, left-hand side, the c plus d cancels, and I'm left with x. On the right-hand side, the c plus d also cancels, and then I find that x is now equal to c minus d. Remembering about restrictions, if we have to note that, I have c plus d cannot equal 0. We could solve that by subtracting d on both sides. And when I subtract c on both sides, I end up with c cannot equal the opposite of d.